So let's come up with an equation that is going to relate the A, the B, and the C for any ellipse. So if you take a look at this picture, the clever thing to do is to put the point that you're talking about right here on one of the co-vertices. And here's the reason why. That means that D1 is going to be exactly equal to D2. And now I'm going to use the Pythagorean Theorem with this little right triangle that's in here. I'll color this thing in. And you use the Pythagorean Theorem, a squared plus b squared equals c squared, and derive an equation that relates these three parameters. So this is all going to be nice and animated for us. So first one is the definition, locus definition says that d1 plus d2 has to be constant, and that constant is 2a, the length of the major axis. Now looking at the picture, now I can use the Pythagorean theorem to find the length of d1. So d1 is going to be equal to b squared plus c squared. So this little segment down here is b, because the length of the whole minor axis is 2b. So we're just using the Pythagorean theorem on that, and then of course take the square root of both sides of this, and I can get the length of d1. Now let's do the same thing for d2. Well, isn't it going to be the exact same length? Right, because of the place where I chose to put that. So let's just go ahead and add those two things together, d1 plus d2. Since this length is the same as that one, I'm just going to have 2 times the square root of b2, or b squared plus c squared. What is d1 plus d2 equal to? Look at the very top of the screen there. It's equal to, watch this, this is phenomenal. Brr, brr, brr. It's of course equal to 2a. Hey look, there's 2's on both sides of that equation. Let's go ahead and divide by 2. And then of course I never look at it with square roots in it. I go ahead and square both sides. And then I take one more step. I usually have c by itself. So what I'm going to do is I'm going to subtract the b squared over here. And this is what it looks like. C squared is equal to a squared minus b squared. It almost sounds like the Pythagorean theorem, right? But instead of having a plus right here, it has a minus. So what I call this is the anti-Pythagorean theorem, Pythag. It's the anti-Pythagorean theorem, and that's the one that relates the A, the B, and the C in any ellipse. Okay? So let's see. Am I going to keep going with this video? Yeah, so this will be it. So this is the same thing that we were looking at before. We had the points 5, 7, and we had the point 5, -1 for the coordinates of the vertices. And then I go ahead and say the length of the minor axis is 4. So that's 2b. That's minor axis is 2b. So b is got to be equal to just 2. What we saw before was that the a value was 8 minus -1. So 2a is equal to 8, and a is equal to 4. If I want to get the foci, I'm going to have to use that anti-Pythagorean theorem in order to get it. That c squared is equal to a squared minus b squared. So c squared is equal to, my a is 4, so that's 16, minus my b is 2, so that's 4. 12, take the square root, c is going to be equal to the square root of 12. Of course, I'm going to rationalize that as 2 square root of 3. Okay, so we have our A, our B, and our C. What was the center point again? The center is the average of those 2 points, and that was at 5, 7, and 6 divided by 2 is 3. Okay, and I needed that point because if I'm going to find the co-vertices and the foci, I'm going to have to go up and down from that point. So let's first find the foci. So the foci, since this was a vertical major axis, this is vertical, and since the foci are on the same axis as the vertices, I'm going to go up and down with these points as well. So the foci, the 5 will stay the same, and now this 3, I'm going to go up 2 square root of 3 and down 2 square root of 3. Since this is irrational, I'll just write it like this, 3 plus or minus 2 square root of 3. Okay, now how about the co-vertices? The co-vertices this time is going to be horizontal, and that's going to change the x-coordinate. And I'm going by 2. So if I start at the center point, I'm going left 2, so that's 3, 3, and I'm also going right 2. Going right 2, I would have 7, 3. Right? I just added that to the x-coordinate going left and right. And there are all the points that we can find for this ellipse. Now we'll go ahead and take a break on this one and check us out in the next video where we do the equations.